In this lesson, we're going to take a look at the sign and range of function values. We'll take a look at the 6 trig functions as they relate to the rectangular coordinate system. And we'll also take a look at finding function values by using the triangle sketch method. So here what we have is the sign and ranges of function values. And what this chart gives us is it gives the signs of the 6 trig functions in each of the 4 quadrants. Notice that the first column, it says that theta is in the quadrant either 1 through 4, and the rest of the columns give us the trig function. So this is how you would read this. In quadrant number 1, if you look across, all 6 trig functions are positive. In quadrant number 2, the sine and its reciprocal, the cosecant, are positive. All of the other 4 trig functions are negative in quadrant 2. In quadrant 3, the tangent and its reciprocal, the cotangent, are positive. Everything else is negative. In quadrant 4, the cosine and its reciprocal, the secant, are positive, and all other trig functions are negative. Now, we can summarize the sign and range of function values by using what's called a mnemonic device. So on the side, I'm going to sketch out an X and a Y coordinate system. And the X and Y axes, they split our plane up into 4 different sections, which we call quadrants. The upper rightmost quadrant is Q1. And then we follow a counterclockwise direction to reveal the other quadrants. So we have quadrant 2, which is to its left, quadrant 3 below, and quadrant 4. And I'm going to put in ASTC, okay, which is a mnemonic, and it stands for the phrase, all students take courses. So in this slogan, all, it alludes to the fact that in the first quadrant, all 6 trig functions are positive. The sign is positive, so I'm going to represent positive by writing out as greater than 0. The cosine is positive, and the tangent is positive, as well as their reciprocals. The reciprocal for sine is secant. It's also positive. The reciprocal for cosine is secant. It's also positive. And the reciprocal for cotangent is, the reciprocal for tangent is cotangent. And in the first quadrant, it is also positive. If we move to our second quadrant, the S in this phrase, students, it allows to the fact that in the second quadrant, only the sine and its reciprocal, the cosecant, are positive. Everything else is negative. The T alludes to the fact that in the third quadrant, the tangent and its reciprocal, the cotangent, are positive. And lastly, courses. The C in courses alludes to the fact that the cosine and its reciprocal, the secant, are positive. Right? All of the other 4 trig functions are negative. So let's put this to use. Indicate the quadrant or quadrants in which the terminal side of theta could be found. So we're given that the sine of theta is equal to -1/2. So we're actually finding which quadrants, okay, all students take courses. Which quadrant can the sine be negative? Well, in the first quadrant, all 6 trig functions are positive, so that angle can't be in the first quadrant. In the second quadrant, the sine and its reciprocal to cosecant are positive, we want a sine value that's negative, so that angle is not in quadrant 2. However, in quadrant 3, the only positive trig functions are the tangent and the cotangent. So a negative sine value could be found in the third quadrant. In the fourth quadrant, only the cosine and its reciprocal, the secant, are positive. All of the other 4 values, including sine, is negative. So we can find negative sine values in the third and in the fourth quadrant. All right, so now let's take a look at functions of angles and values. All right, so now we're going to take a look at the 6 trig functions as they deal with x, y, and r and are in a rectangular coordinate system. So you notice in the diagram that we have a rectangular coordinate system. We have an x-axis and we have a y-axis. All of our angles are in standard position, so they all start along this positive x-axis. And we can see in the diagram that we're given the point in the second quadrant that lies on our terminal side. And through that point, we can draw a ray. This gives us our angle theta. You should always drop a perpendicular to the x-axis only. So from my point in the second quadrant, I drop a perpendicular to my x-axis, and this gives us a right triangle where we can use right triangle trig. So we never really solve for r. We solve for, well, we never really solve for r squared. We always solve for r. So to simplify this formula a little bit, I'm going to take the square root of both sides. So if I take the square root of r squared, I get r. If I take the square root of x squared plus y squared, I get the square root of x squared plus y squared. So if you're ever in need of finding r, you would simply use this formula. It's equal to the square root of x squared plus y squared. Also, using that Pythagorean theorem, there are 2 more formulas. X, that equals to the square root of r squared minus y squared. So if you ever had to find x, you could use this formula. And then lastly, y is equal to the square root of r squared minus x squared. Okay. So here are our Pythagorean formulas. In order to find the 6 trig functions, however, notice that the sine of some angle is y over r, the cosine is x over r, and the tangent of some angle is y over x. So notice all values can be pulled from your imaginary right triangle. The formula for the cosecant is r over y. So notice that the cosecant and the sine are reciprocals. So the sine is y over r, the cosecant is r over y. The reciprocal of cosine is secant. Secant is r over x. The reciprocal of tangent is cotangent, and cotangent is x over y. So we're going to use these things to find trig functions. So let's take a look at this problem. All right, here we're given an angle that's in the 4th quadrant. We're given that point P has the coordinates -1, -3. We're asked to find the sine of theta, the cosine of theta, the tangent of theta, and also the reciprocals. The reciprocal for sine is cosecant theta. The reciprocal of cosine is secant theta. And the reciprocal of tangent is cotangent theta. All right, so the first thing I'm going to do is drop a perpendicular to the x-axis. I'm going to blow this up slightly. And I draw my right angle symbol, and this is our right triangle. So notice here we have x. All right, that's the value for x. Here we have y. And here we have r. So notice that they give us the x and the y value, right? X is positive 1, so x is 1. And y is negative 3, right? Because I'm at the origin, I go one place to the right, which is positive, and I go down, which is negative. So in order to find our 6 trig functions, we need to know x, y, and r. So from this point, I'm going to find r by using that Pythagorean formula. R is equal to the square root of x squared plus y squared. I'm going to substitute x for 1 and y for negative 3. So r is equal to the square root of 1 squared plus y, which is negative 3 squared. 1 squared is 1, negative 3 squared is 9, so r is equal to the square root of 10. So now we have everything we need. We know that x is 1. We know that y is equal to negative 3 and r is equal to the square root of 10. So I'm just going to put all of these 3 things together and find the trig values. So remember that the sine of some angle, that's y over r. So if I look below, the y value is negative 3, the r value is 10. So the sine is negative 3 over the square root of 10. The cosine of some angle has the formula x over r. My x value is 1. My r value is square root of 10. So I have value 1 divided by square root of 10. The formula for the tangent is y over x. So I have negative 3, which is y, over 1, which is x. So the tangent is simply negative 3. The reciprocal of sine is cosecant. So I can reciprocate or flip this value over, right? The cosecant formula is r over y. So that's negative square root of 10 over 3. The formula for the secant is r over x. So that's going to give us the square root of 10. The formula for the cotangent is x over y. And that should give us negative 1/3. You'll notice in these solutions, I did not rationalize the denominator simply because the XYZ homework platform will accept radicals in the denominator. All right, now lastly, we'll take a look at finding function values using something called a triangle sketch. So in the next problem, we're asked to find the exact value for sine if the cosine value is -5/3 and is in the third quadrant. So here I'm going to sketch out an angle in the third quadrant. I'm going to attach all the given information. I'm going to use that given information to find the sine. So firstly, let's sketch out an angle in the third quadrant. All right, so remember that all of our angles start along this positive x-axis. I'm going to arbitrarily place a point in the third quadrant. Through that point, I'm going to draw my end ray. This gives us our angle, right? This is our angle theta. I'm going to drop a perpendicular to the x-axis always. Right? So this gives us our right triangle. I'm going to blow this up slightly. So now that I have my angle in the second quadrant, I know that this is the distance for x, right? Because if I'm at the origin, I would have to go to the left, right? So that would make x negative, have a negative value. And then I would have to go down, right? So that would make both my x and my y values negative. And along here, we're going to have r. So now one thing just to keep in mind before we continue, and if you have ordered pairs, if your ordered pair is in this first quadrant, both x and y are positive. If your ordered pair is in the second quadrant, the x coordinate is negative, the y coordinate is positive. If your ordered pair is in the third quadrant, both the x and the y coordinates are negative. Okay, we'll see how this is going to play a part in just a second. And if your angle is in the fourth quadrant, your x coordinate is positive, y coordinate is negative. All right, so I know I'm in the third quadrant. My x coordinate should be negative, and also my y coordinate should be negative. All right, so we've sketched out an angle in the third quadrant. The next thing I want to do is plug in the given information. So what are we actually given? Well, we're given that the cosine of theta is -5/13. So remember, in our cosine formula, the cosine is x over r. So remember that r always has to be positive. So whenever you're dealing with a negative number, that negative value is in the numerator. So given this cosine value of -5/13, I know that x is -5 and r should be 13. If I'm asked to find the sine, right, that's what we're actually asked to find, I need to know the y value and the r value, right? Because the sine of some angle is y over r. Well, we're given r, right? R is 13, but we're not given y. But we can find y by using the Pythagorean formulas, right? So in order to find y is going to equal to the square root of r squared minus x squared. I'm going to substitute r for 13 and x for -5. So that's 13 squared minus a -5 squared, which is 169 minus 25. which is the square root of 144, which is 12. And this is where you have to be careful, because mathematically we're given a positive 12. But if we take a look at our triangle sketch, and if we keep in mind the signs of our ordered pair, I'll notice that this -5, so keep in mind that x should be -5, right? Because if I'm at the origin, I would go to the left 5 units. Y should be -12 because we go down, right? So y is -12, and r, which is always positive, is 13. Right, so here is why the triangle sketch is so important, is because you can catch those sign values. Right, so I got positive 12 in the math, but my sketch shows me that it should be a negative. So I'm going to substitute y for -12. So that means that the sign of theta should be -12 over 13. And we'll take a look at one more. We're given that the cotangent of theta is equal to -4/3, and it's in quadrant 2. We're asked to find the cosecant. So we're going to repeat the process. We're going to sketch an angle in quadrant 2. We're going to plug in the given information. Then we're going to solve for a cosecant. All right, so here's our XY axis system. I'm going to arbitrarily place a point in the second quadrant. Now, when you hear me say arbitrarily, I'm just placing a point pretty much anywhere in the second quadrant. Nothing really special. I can move it around. That's why it's called arbitrary, just for initial setup. So we start along the positive x-axis. I'm going to draw a ray through that point. I'm going to drop a perpendicular all the way to the x-axis. A right triangle is formed. Here we have x. Here we have y. And here we have r. So recall that we're in the second quadrant, and if we're in the second quadrant, the x value is negative and the y value is positive. All right, so now let's plug in the given information. So we're given that the cotangent of theta is -4/3. So if you take a look at your formulas, the cotangent has the formula x over y. So now I have to distinguish which ordered pair is negative based on the quadrant. So like if I'm in the second quadrant, my x value should be negative and my y value should be positive. So x is going to equal to -4. Y is going to equal to +3. And now we're going to find r. Right? Because for the cosecant has the formula r over y. So we already know y, right? Y is 3. So next we have to find r. So we're going to use that Pythagorean theorem. R is equal to the square root of x squared plus y squared. I'm going to substitute x for -4 and y for 3. So this is -4 quantity squared plus 3 squared. That's 16 plus 9, which is 25, and the square root of 25 is 5. Now, since r is always positive, my solution here is positive 5/3.